Hello and welcome everybody. So if you're trying to learn about the maximum likelihood algorithm, then this is the video for you. In this video, we're going to apply the maximum likelihood process in order to classify pixels, in a satellite image, right? So in order to do this process, we need to ask the following questions. The first question is, what is it that we're actually trying to classify? In our case here, we're trying to classify pixels of an image. So the classification is going to be on the pixel level, right? So where we are actually trying to get is something like this. Okay, so you know that green color represents a class, the blue color represents a class, the red represents a class, and so on and so forth, right? So the second thing that we're actually trying to answer over here is, how many dimensions does our pixel have? Okay, is it one-dimensional, two-dimensional, or three-dimensional, or what? Okay, so in our case, our pixel has got three dimensions: the R, the G, and the B, whatever the order is. Okay, so in our situation, we have a three-dimensional classified object. Okay, yeah. Now, the third thing that we should actually do right now is we should generate our classes. So how do we classify a three-dimensional object? What we will do is we do the classification on each dimension separately. Okay, so we will work on the R projection of the pixel. Okay, so how do we classify on one dimension? Okay, so here let's assume that we just have this X dimension over here. How do we classify on the X dimension? We start to generate classes on that specific dimension using a training data we have. Okay, so we should have training data. In our case, we should have a bunch of pixels that we call class, let's say 1. Okay, and we should have a bunch of pixels that represents class 2 and class 3 and so on and so forth. So in our situation over here, we have those images. Okay, so this image represents the training data for class button. This image represents the pixel group set of buildings. Okay, this training data represents the class road, and this data represents class water, and this data represents class forest. So in order to be able to generate the classes, we need those training data. So right now, the next step we are going to do is start generating the classes on each dimension separately, right? Okay, yeah. So how do we generate a class? How do we actually generate a class? In order to generate a class, we will get the bunch of pixels in that particular class which belong to that particular class, and we will use them to calculate those two values, which is the average value and the standard deviation. Now, so let's assume that we have a pixel, with three values R, G, and B, as we know. What does this X represent? Now, when we are doing the classification on the R dimension, we will be dealing with the R values of that pixel. If we're doing when we are doing the classification on the G dimension, we will be dealing with the G values of that pixel. And so on and so forth. The same thing is substituted in this formula. So those x's represents, let's say, the R values of the pixel if we are when we are actually classifying or generating the classes on the R dimension, and the same happens on the G and the B dimensions. So we will be, for each class, we will be generating classes on the R dimension of the on the R dimension, and we will be generating classes on the G dimension of that class, and we will be generating classes on the B dimension as well. Now let's assume that we have generated our classes how do we actually make the final classification of the whole pixel? The classification of the whole pixel is going to be the multiplication, okay, of the classification on the of the pixel on the 3 dimensions. Okay, so we will classify the pixel on the r dimension by substituting on this formula, okay, and we will classify the pixel on the on the b dimension, and we will classify the pixel on the g dimension. Okay, now the result of the multiplication is going to be the likelihood of the whole pixel to belong to a certain class. Now, the best way to understand this whole process, I know this is not so much clear right now, so the best way to understand the whole process is to have an example. In our case, I have a MATLAB code. Okay, yeah, it's not rendered in MATLAB because it slows down my device, but it is a MATLAB code. Okay. All right, so in our situation over here, what first I did is to input the training data for the classes. Okay, so we have the water class and the image of the water I showed you before, the building class, the image of the building I showed you before, that white picture, and the same for the rest of the classes. Okay, now here I'm just rearranging the matrices to suit my code, nothing scary over here. All right, so right now, as I say over here, you will calculate the mean and the standard deviation for each class on each dimension, right? Okay, so the layer over here I have represents the dimension, okay, we are dealing with, because you know when you input an image into MATLAB, you will find out that it's actually 3-layered matrix. Okay, the first layer represents, let's say, the R, and the second one represents the G, and the third one represents the B, or a different order, whatever the order is. Okay, very nice. So right now, for each class, we will calculate those two values, which are the mean and the standard deviation, on the for each of the dimensions, for each of the layers. Okay, so we have over here, okay, so we will calculate the average value and the standard deviation for class 1 layer 1, for class 1 layer 2, for class 1 layer 3, okay, and then for class 2 layer 1, class 2 layer 2, class 2 layer 3, and so on and so forth. And you know that we can use a for loop to make that all in one single for loop, but I don't want to make it complicated right now. Okay, so class 2 layer 2, class 2 layer 3, and so on and so forth, and until you can compute the classes for all the layers. Okay, so this all is just about computing the classes based on the training data we have just shown you. Right, very nice. Now, for the classification process, for each pixel right now, how do we, right now, let's assume that we have calculated our classes using the training data, and right now we have a new pixel that we want to classify based on what we have. How do we do that? Okay, right now you will understand what I'm actually talking about. Now, for each pixel, okay, for each pixel, we will compute the likelihood, okay, of that pixel belonging to class 1, according to this. We'll compute the likelihood of the pixel belonging to class 2. We'll compute the likelihood of the pixel belonging to class 3, 4, and 5. And right now, the maximum value among those 5 is going to be the class of this pixel, okay, we're actually trying to classify. So how do we compute the likelihood of the pixel belonging to class 1? Well, we'll compute the likelihood of the pixel belonging to class 1 layer 1, and we will multiply that by the likelihood of the pixel belonging to class 1 layer 2, okay, and then we'll multiply that by the likelihood of the pixel belonging to class 1 layer 3. So what is this formula I'm highlighting over here? It is what I have showed you, okay, over here, okay, and we will use the values, okay, of that specific particular class, right? Okay, we have calculated the average and the standard deviation. Very nice. Okay, I think this is clear. And then what I do in my code is actually, after finding the class of the image, I will give that corresponding pixel a color, okay, based on its class. So if it's class 1, I will give it blue. If it's class 2, I will give it white, and 3 and 4, and so on and so forth. The result is going to be something like this. Okay, so if the image is classified as green, it will have the green color. If it's classified as a building, it will have the white color. If it classified as water, it would have the blue color. If it classified as road, it will have the probably the black, and if it classified as barren, it will have the red color. Right, guys, I hope this was kind of like a fast breakthrough into the maximum likelihood process algorithm, and I hope that you benefited something out of it. Thank you very much.